Now that we've introduced differential equations, we're going to be focusing on the solutions to those differential equations. So a solution to these equations are going to be functions. They're not going to be numbers necessarily or variables. It's going to be an entire function that represents the solution. So when we see the variable y in these equations, that represents what we're trying to solve for. And that is like y equals f of x, a function. When we see y prime or dy dx, that is the derivative of the function that we are trying to find when we're trying to solve these differential equations. So the purpose of this video is really going to be to nail that idea down, that we're looking for functions and how we can kind of think about finding those functions. Note that you can spend years doing all different kinds of processes, finding different ways to find solutions to differential equations. We will be focusing on fairly simple differential equations in this class and ones that we can kind of easily find solutions for. So let's look at three examples to start with. Our first one is y prime equals 0. This is saying that the derivative of the function, so the derivative of our solution, is 0. We're trying to find our solution. So we're given the derivative, can we find the original function? And what this is really saying is that the antiderivative dx is going to be our answer. Note that y is a function of x. That's why we're doing this in terms of x. So the antiderivative of 0 is just going to be a constant. So we can say that y, we'll write it like this. We'll say that a solution to this equation is y equals any constant. For example, if you take y equal to 2, that's an answer because the derivative of 2 is equal to 0. It satisfies that equation. So what we're going to say, and we'll introduce this on the next page as well, is that this is a particular solution. That's one solution that works. In general, we are going to be looking for the general solution, and that is y is equal to any constant. We'll call any constant c in that case. This is what we call the general solution. All right, so we're starting with an easy example, y prime equals 0, and we can just think about the antiderivative of that function. Let's do the same thing for the second one. Now we want the derivative of the function to be x. So we are looking for the antiderivative of x with respect to x, and we know that this is going to be equal to 1/2 x squared plus c, any constant. And this is our general solution. A particular solution might be 1/2 x squared minus 5, adding the constant -5 to that. And we can double check that this is a solution by taking the derivative of 1/2 x squared minus 5. The minus 5 would just zero out, and we'd be left with just an x, which is what we know should be what we have here. So these first two examples show that in solving differential equations, the biggest thing that we're going to think about is we're going to take the antiderivative, the integral of the function that we're looking for. Unfortunately, it's not that easy, as differential equations can be much more complex than just y prime equals a function of x. If it were that way, we could always do this. So this third example shows what can happen outside of that. So here we have the derivative of our function is equal to our function. So let's put this in words. The derivative of the function is equal to the function that we are looking for. Now, in this case, we can't take an antiderivative because we don't even know what y is. There's going to be other ways that we can find solutions here, but for us right now, we're just going to try to reason out what is a solution to this. I urge you to pause the video at this point and try to think about, do you know a function whose derivative is itself? And there are really kind of two options here. You may have thought about the function y equals 0. That is a solution to the differential equation because you have 0, the derivative of 0 is itself 0. Past that, you also have e to the x is a solution because the derivative of e to the x is itself e to the x. These are particular solutions. We could write the general solution as y is equal to any constant times e to the x. So over here, let's box this first. This is the general solution. Note that this is the case where c is equal to 0. This is the case where c is equal to 1. And any constant times e to the x has its same derivative. You may be able to find other solutions that may look different, but they could all be written in this form. We're not going to show exactly why that's true, as that will be for a later section and maybe even a later course. All right, so continuing on this idea, let's look at a more complex differential equation. In this case, we have, again, a differential equation is any equation that has a derivative in it. It does not have to look like y prime equals. So here's one. We have x y prime minus 4y equal 0. And we are going to test whether y equal x to the fourth is a solution to the differential equation. So what this means is that if I plug in y equals x to the fourth, and I plug in the derivative of x to the fourth, and for y prime, it should satisfy that equation. So here we have x y prime minus 4y equal 0. We have that y we're going to replace with x to the fourth. And we have that the derivative of x to the fourth is 4x cubed. And that's what we're going to replace with y prime, or we're going to replace y prime with 4x cubed. So if this equation is satisfied, then this is a solution. So looking at this, we have x times 4x cubed minus 4 times x to the fourth. Well, that's going to be equal to 4x to the fourth minus 4x to the fourth, and that's equal to 0. And that is what we should get to satisfy that equation. So we're going to say that y equals x to the fourth is a solution to that differential equation. Is a solution to the differential equation x y prime minus 4y equals 0. This does not mean that it is the only solution. In fact, it is not the only solution, but we do know it is a solution. And that's how we're going to check if something is a solution or not. So as I just said, there's never going to be just one solution to a differential equation. And we can think about why this is true, as it's the same reason why there's not just one antiderivative to a function. When you take the integral of a function and you find all antiderivatives, you have to add the constant plus c to the end of your antiderivative. The reason we do that is because that represents all antiderivatives, which is going to be an infinite family. So going back to these words we introduced on the first page, the general solution is an expression that gives all solutions to a differential equation. This is our idea of the plus c, and all the general solutions will include a constant c somewhere in them. A particular solution is going to be just one solution corresponding to a particular value of c in the general solution. Often what's going to be the case is we're going to find a particular solution to a differential equation by solving an initial value problem. And we'll show what that is on the next page. So here's how a problem could look like. Find the general solution to the differential equation y prime equals 2x. And we're going to do some graphing just to kind of show what's going to go on. But then given different initial conditions, and we'll talk about what these mean, we're going to find particular solutions to the differential equation. So first off, let's find the general solution. We've done this a few times. We have y prime equals 2x. The solution is just going to be the antiderivative of 2x with respect to x, and that's going to be x squared plus a constant c. And there is a general solution to the differential equation. It's x squared plus any constant. If you take the derivative of that, you get 2x. So now let's think about these particular solutions. And we have three of them. So first of all, let's look at y of 0 equals 0. This is saying that x is equal to 0 and y is equal to 0. Y is a function of x. We can think about this as f of 0 equals 0. So we have that y is equal to x squared plus c. And we are going to solve for c given this initial value, 0. If when x is 0, y is 0. And we can plug that in to the differential equation. So again, we have x is equal to 0. So we're going to plug that in, 0 squared. We have y is equal to 0. So we're going to have that 0 on the other side. And then we have our plus c. And this is just going to give us that c is equal to 0. So our particular solution is y is equal to x squared plus 0. Y is equal to x squared. All right, let's do this again. This time we're going to do it with y of 0 equals 4. So here the x value again is 0. And the y value in this case is 4. So we have, again, the x value is 0. The y value is 4. So we have 4 equals 0 squared plus c. That means that c is going to be 4. So our particular solution is x squared plus 4. One last time. So here in our last one, we have y of 4 equals 0. This is different than the last one. This time we have x is equal to 4. Y is equal to 0. So plugging this in, we get 4 squared, 0 on the other side, plus c. That's going to be 0 equals 16 plus c. This is going to be c is equal to negative 16. So y is equal to x squared minus 16. And what I ask in this question is let's also graph these particular solutions, see what these solutions are going to look like. So the graph of y equals x squared, we're just going to do a little parabola here. The next one is y equals x squared plus 4. So we'll say that's moving up 4 units. And the third one's going to be x squared minus 16. That's moving down 16 units. And what I want to draw your attention to is that we said that when we have this initial condition, this is like the point x equals 0, y equals 0. And this is indeed the solution that goes through the point 0, 0. That's corresponding to this equation, y of 0 equals 0. The next one we have x equals 0, y equals 4. And again, that corresponds to the point 0, 4, the condition y of 0 equals 4. And finally, we have that this x equals 4, y equals 0 is going to correspond to this point right here, 4, 0, which corresponds to the condition y of 4 equals 0. So another way to think about initial conditions is that they are points that our solution goes through. There's only one solution that's going to go through that. This x squared plus c, the general solution represents all parabolas. X squared plus something that's going to be any vertical translation of x squared. You talk about it going through a specific point, and that's an initial condition. We'll do some more practice problems in the next video corresponding to these ideas.